All right, this lecture is going to be kind of a review of electric circuits. We're going to be doing circuit diagrams, and we're going to be making sense as to the circuits we'll be creating in class. So circuits can be represented by using circuit diagrams. These will help us simplify the electric circuit system, and we can talk about this picture here. We can draw it with a series of labels in drawings. Circuits provide paths for currents or charges to move or flow within a conductor. So the wires are metallic because they're very good conductors. And electric circuits are common to our lives, as electricity is useful to life as we know it. This picture isn't truly represented here, and here's why. Even though it has a bulb and it has a switch and it has a battery, even labeling the cathode and anode, if you notice, this switch here would be an open circuit, but the bulb is on, so that implies it's closed. So technically that's not even completely correct, but we get the idea. We're still talking and going to be drawing electric circuits using these circuit diagrams. Some simple language is open and closed circuits. Open circuits do not allow for current to flow. In the picture, you should not be able, or you should be able to see that the switch is not connected. Thus, the circuit is open. The light bulb is not on for a simple reason. No current is flowing through the wire. But the bottom picture is a closed circuit, and this allows for current to flow. Current is said to flow from the cathode, the positive end of the battery, right, the 1.5 volt battery we'll be using in class, to the anode, the negative end. So current is said to flow this direction. We see the light bulb is on, thus current is flowing. So drawing circuit diagrams. So parts of the circuit boards that we will use in class contain each of the objects in the picture to the right. So we'll be using wires, batteries, bulbs. We've got resistors. They look different than this, but we can draw them with these squiggly lines. And notice a light bulb is a resistor. It's kind of got some squiggly lines. That'll be the filament that's actually heating up, and we'll talk about that a little bit further. And then a switch. Notice in the picture it shows that it's closed, but in the diagram it actually shows it's open. So don't get that confused. Just make sure you're drawing it open when open and closed when closed. So we'll be using 1.5 volt batteries. Resistors will be color-coded. They're green, red, and blue. A variable resistor, they're sometimes called potentiometers. They simply control the amount of resistance in the circuit. And then a switch, we're opening and closing the circuit. It's like a light switch, is simply put. When you watch this video, be careful. I made a mistake on the video. I said Coulomb's law when I meant to say Ohm's law. So Coulomb's law is the relationship relating charges and distance of the charges to the electric force. This is what we talk about with electrostatic topics. Ohm's law, voltage equals current times resistance, is used for electric circuits. My bad. I did not. I just rewatched the video and caught that. So, but I like the video itself, and I don't have another video created right now. So be sure to watch the video and get caught up on that. So Ohm's law is going to be our go-to, that voltage equals current times resistance. And you'll find that current and resistance have an inverse relationship. So if we draw a circuit diagram of the circuit in the picture, you'll see you have a 1.5 volt battery. The total voltage is 1.5 volts. I have my cathode, I have my anode, I have a bulb on the top of the circuit, a bulb at the bottom, and a closed switch. Therefore, current is flowing. Current flows from cathode to anode. So the question I'm asking you is this. What would happen to the brightness if I added a 1.5 volt battery? Well, you should see that if I double the voltage, I will double the current. I didn't change anything with the number of resistors. So the total resistance is constant. By doubling my voltage, I double the current. However, if I add 2 bulbs, if I double the number of resistors, I'm going to be decreasing my current. We're assuming that the voltage is constant. So doubling resistance is going to be 1/2 of the total current. So the bulbs, we'll see them as getting dimmer. There's your introduction to circuits.